Here we go. Standard form of polynomial equations of quadratics. See, I didn't even say it right off the bat. So first of all, the first thing is we're going to label these things by degree. And I wonder if you know how this works. Degree means, like, for example, you know what, let's go down here and define it. Degree. Okay. Degree is the highest exponent in an expression. Okay. So what I mean by that is, like yesterday we talked about things where x squared. X squared. Anybody remember what x squared functions are called? I'll give you a hint. Look at the top of your notes from yesterday.
Parabola.
No, that's the graph of it. Quadratic. Okay? So let's go back in and under degree 2, let's write the word quadratic. Okay. And that is x squared. That's what that looks like. Okay? Or 3x squared, or negative 7x squared, or 1/2 x squared. It's just x squared. Anybody remember what it's called when it's just x? And I'll give you a hint. Y equals mx plus b. You're getting there. Even more of a hint. What does the graph of y equals mx plus b look like? And slope-intercept is the name of it, yeah. But what does that graph look like? A line, which is linear. That's the word. Linear. Okay? Linear. All right. How about, let's keep going backwards here. What if I just have a number? I'm going to just put number, but you could put any number there. 3, 10, whatever. Anybody remember what that's called? Close. That's the number in front of the variable. We're actually going to get to that. Anybody else? It starts with a C. Better be careful. Constant. Constant is the word. Everybody's been here all day. It's crazy. All right, how about the third? This one isn't that hard. X to the third power. Anybody know what that's called? Cubic. That's exactly right. It's x cubed, right? Remember that? Cubic. Okay. And I'll be really impressed if anybody gets x to the fourth or x to the fifth, because I don't think you've probably heard those before. Anybody? X to the fourth or x to the fifth? Once you hear x to the fourth, x to the fifth is easy. Let's just write it down there. Quartic and quintic. Now, 6 or more, there is no names for that. It's literally just 6th degree or more. So if it's 7th degree, 6th degree. So if it's 7th degree, 8th degree, 9th degree polynomial, that's what you would say. Okay. I'm not going to give you examples that are 6 or more. I want you to memorize those words to the point where on your quiz, which I just recreated today, not till next week, by the way, your quiz is going to ask you to, well, we're going to see it down here at the bottom, to label it by using the name and the degree. So the number of terms, this one's easy. Remember what it is when I have 2 terms? That's the easy one. Anybody remember what, if I have, for instance, this, 2 terms. What is that called? Or 1 term or 3 terms. Anybody remember any of those? I bet when I give you the first one, you'll know it. 1 term by itself is called a monomial. I'm going to give you an example, 3x squared by itself. What's the next one, Trey? Binomial. Binomial. And let's give you an example of that, 3x squared plus 4. And then last one, 3, trinomial. Which would be like 3x squared plus 4x plus 5. 3 terms, 2 terms, 1 term. How about if there's 4 or more? There's not actually a name for that either. It is polynomial.
More than 1, right?
Of 4, and I'm going to put or more, depending on, so if it's 5, you say have 5, if it's 6, you say have 6 terms. A polynomial of 4 terms, a polynomial of 5 terms, and so on, okay? So, there's that. A couple more definitions here before we get to what we got. Coefficient. Trey, you kind of already said it. Do you remember what I said in response to it? What is a coefficient?
Oh, it's
almost exactly. The number, I'm going to say attached, because it could be in back, right? Attached to the variable. So, for instance, in 3x squared, it's 3. It's not 3x squared. It's just the number attached to the variable. But if I wrote x4, it's still 4. Okay, it's not necessarily always in front. Okay. The leading coefficient then is, well, it's still a number attached, but the leading coefficient is the number attached to the variable with the highest degree. Or if you prefer, slash exponent. Give me a second, let me zoom that in just a little bit. Okay, so it is the number attached to the variable with the highest exponent, or degree. Which kind of leads us to degree, but we already defined that anyway. It's the highest exponent in an expression. So when you look at, say, number 2, what's the highest exponent in number 2? What's the highest exponent here in this problem?
2x.
Right, the 3, right? So this tells me what the leading coefficient is that 2 that's attached. Okay. Let's keep going here. Standard form, and this is the big key of all of this. Standard, to write something in standard form is to write, so I'm going to put writing a polynomial in order from highest to lowest exponent. So an example of quadratic would be, well, I kind of wrote one up above, 3x squared plus 4x plus 5. An example of a cubic, so again, in standard form, the 2, the 1, which isn't there, but it's there, and the 0. Cubic would be, I don't know, 5x cubed minus 4x squared plus 5. I don't have to have an x term in there. I don't even necessarily have to have an x term in there. Matter of fact, all I could do, I could just write this, but I'm trying to have you see that in standard form, matter of fact, let's attach it there because I think it helps. X plus 2. So you can see from 3 to 2 to 1 to 0, they're all in standard form in order. All right, let's get to the nuts and bolts of this, the actual examples. Simplify, move this up here. So this is the big thing that I'm going to ask you to do on the quiz as well. Simplify each equation into standard form and identify the leading coefficient. Let's do that first. Number 1. Is it in standard form already? Yeah, because I don't have any squares or anything that I have to move around. So let's just rewrite it in standard form, which is literally just rewriting the problem as you see it. Okay. What's the leading coefficient?
3.
Close. Negative 3. Okay. Because it is the term, the number attached to the highest exponent. And what is the name of this? So by name, I mean we have to say both the degree and the number of terms. So what is the degree here? Linear. And how many terms do I have? 2 terms. So that means it's a binomial. So its name is a linear binomial. Okay. Let's do number 2. Is it in standard form? No, why not?
It's not ranked from highest.
It's not ranked from highest to lowest. I love it. That's actually a great way to say it. So let's write it from the highest to lowest. What would I write first? 2x cubed. Keep going. Minus 3x to the second. Keep going. Plus 7x first, and then minus the 10. The constant term is always going to be last. Okay, the one without the x is always going to be last. What's my leading coefficient here? 2. And I want to point something out. The last one was really easy. This one, if you don't rank it in order, You're probably going to say the leading coefficient is 7, but that's not. The leading coefficient is on the highest exponent, okay? Name. Well, what's the degree? Close.
Cubic?
Cubic, why?
Because there's exponent of 3.
Because the exponent is 3. Okay, so cubic. And then what? Polynomial of 4 terms. Anything over 3, that's how we say it.
Do we have to say polynomial over 4 terms
Yes.
all the time?
Yeah, unless that's 5, then you say polynomial of 5 terms. There, if it has 6, you say polynomial of 6 terms, that's all. So yes, you do have to say that, okay? How about for the next one? Is it in standard form? No, so what do I write first?
Negative 7x.
Negative 7x squared, plus or minus 4?
Plus.
Plus 4, it would have negative in front, right? Leading coefficient then, of course, is negative 7. And what's the name? Quadratic. What is it? Quadratic binomial. This ain't so bad. Alright, so now we're going to get into a little work on 4 and 5. What should I do on number 4? We actually have to do some math before we can name it. What should I do on number 4? Simplify, right? And really, because that's just a plus sign, it's just really combining like terms, right? This becomes a squared plus 2a minus 6 plus 3a squared plus 40, right off the bat. And combine like terms. I've got an a squared and an a squared. And really, I'm picking the highest exponents to simplify first. That gives me 4a squared. Gotta get those out of there so I don't do it again. I got one a term, so plus 2a. What is negative 6 plus 40?
34.
34. Positive 34. Now I have written it in standard form. I want to keep going. I'm going to have you guys fill in the rest of it. Yes?
Can you zoom in a little bit?
Yes. Thank you.
Is it 40 squared?
That's 4a squared.
Oh, gosh.
Yeah, my a's kind of look like 9s and 0s sometimes. What about the next one? What do I do in the next one? We'll come back to that other stuff. What do I do in the next one? What does this minus sign mean I have to do? You remember? It's subtraction, of course. And what it really is, guys, maybe put this 1 here, because I'm distributing a negative 1 onto every term passive. So I'm going to rewrite this. The first term doesn't change because there's no negative in front. Minus 2x to the 5th. Negative times a negative is plus 2x. Negative times positive is negative 5. And now I can do like what Rester said on the other problem. Combine your like terms. What's x to the 5th minus 2x to the 5th? Well, negative 1x to the 5th. Get those out of there. I got a negative 2x plus 2x. What's negative 2 plus 2? 0. Oh, they just go away then. How about 5 minus 5?
0.
They just go away too.
That was just it.
So what is this called? First of all, leading coefficient is negative 1. What is this called? Quintic, because it's to the 5th power. A quintic monomial, that's right. Before we switch to the next page, fill in the 2 blanks that I left right here. Fill those in a second. Probably 30 seconds. Is that what you had? Leading coefficient is 4 because it's attached to the highest exponent, and it's a quadratic because it's squared, trinomial because it's 3 terms. Easy enough? Let's go to the next page. And now you're not going to be able to look at them. See if you can remember now. What are you doing number 6? We're going to get a little more challenging problems here.
Wait,
Anybody remember that? What's that?
So on the quiz, we're not going to have, are we going
The terms? I'm going to have you memorize the terms. The more you do it today, the more that will stick in your mind, I promise. And the more we'll talk about it between now and then. Okay? What do I have to do in number 6? Anybody remember that naughty 4-letter F word? Careful. Foil! That's it, yes. Okay. That's right. Foil. Okay. Now, let's FOIL it out. So here's 2x times x is 2x squared. Outside means this. And 2x times negative 3 is negative 6x. Inside is 4 times x, which is 4x. And last is 4 times negative 3, which is negative 12. And then you can see how fun this can be, because if I put a dot there and a dot there, it looks like Stewie's face. Family Guy. Okay. Now combine my like terms here. I've got 2x squared minus 2x minus 12. I've simplified it to standard form. Once I FOIL it out, it's just combine those two middle terms. And I think you guys can do the rest. So let's go on to number 7. Okay. I'm gonna fill some of these in. I'm gonna leave some of these blank and have you guys fill it in. Number 7. Am I going to FOIL on number 7? No. Why am I not going to FOIL? You're right. I'll come back to that. Why am I not going to FOIL? What's the difference between 6 and 7? That's right. I have numbers in front of that I have to distribute. Whereas on number 6, there's parentheses right next to parentheses. I need you to see the difference there because there is a difference. There is some numbers in between. So I need to distribute this negative 2. And I need to distribute the negative 3x into both of those terms. Come back to it. Let's look at number 8. What do I have to do in number 8? FOIL again, right? Somebody tell me, please, what is x squared times x squared? And that's what everybody thinks. It is x to the 4th, but it's not 2x to the 4th.
It's just 1x.
It's 1x to the 4th. Here, I'll tell you why. Let me give you just a real quick example. If I have a marker that I can do it with, then I would. If I have x times x, let me make it right over here. If I have x times x, and I have x plus x, plug in a term, plug in 3. What's 3 times 3? 9. What's 3 plus 3? 6. Those are two different answers. This answer is x squared, because guess what? 3 squared is 9. This answer is 2x, because 2 times 3 gives me 6. So the 2 doesn't come. It's just x squared times x squared is x to the 4th. Let's keep going here. This gives me negative x squared. This gives me positive x squared. And then negative 1 at the end. I'm going to leave that up there. And then we'll talk about number 9. What do I do on number 9? FOIL. Now, it's a little more than FOIL because there's 3 terms. There's a trinomial times a binomial. So really it's distribution. But it's the same concept as FOIL. We multiply every term by every other term. So let's kind of start working this together. What's 3x squared times 4x? 12 x to the 3rd. Then I'm going to take 3x squared and times it by 5. What's 3x squared times 5? Plus 15 x squared. Let's keep going. Let's do the x. What's x times 4x? Yep, so 4x to the 2nd. And I've got x times 5, which is 5x. I got negative 1 times 4x, which is negative 4x. And I got negative 1 times 5, which is minus 5. So what I want you to do is finish up all the stuff I didn't do, which means simplify 8 and 9 and fill in the blanks, and do 7 on your own and fill in the blanks. It's going to take about 5 or 6, maybe 7 minutes, depends how long it takes. Okay?